Hi, everybody. We're going to go ahead and get started. Are we okay? Yeah, okay. Hi, I'm Yvonne Ajay. I'm the VP of Benefits, and I sit over normally at 123. And it's my pleasure today to welcome Dr. Jeff Sutherland, who's going to talk to us about his new book, Scrum. How many people have heard of Scrum, the term? Oh, wow. Okay. So I'm completely outnumbered, and you probably all know that it's a term that comes out of rugby, which I did not know before reading the book. But he's going to talk to us about Scrum, which is an approach to work and project development that he's used in different areas. I'm not going to go too much into his background because he's going to go into that as he tells the story. One thing I will say is that in reading the book, it really resonated with me about how we work at Google, the idea of working in small teams, providing a lot of autonomy, having managers get out of the way and really facilitate the work that their teams are doing. So without further ado, join me in welcoming Dr. Jeff Sutherland.
Thank you very much. I've been doing a book tour for the last couple of weeks, and last week I spent a lot of time in Silicon Valley meeting with all the larger companies there, but I didn't hit Google this time, so I'm doing Google here in London. The talk about the book started with a TED Talk, and they had this video front-ending my TED Talk, which I really liked because it was kind of the French view of what Scrum is. So they had these big concrete blocks then shattering on the pavement. And then they said Scrum is about hacking leadership, which Google has done a great job of, but most companies have a problem with it. The TED Talk was in France, so I decided I'd start by talking about the Declaration of Independence because the French had helped us win the American Revolution. They sent General Lafayette over to fight with George Washington, and then some years later they gave us the Statue of Liberty. So I went back to the Declaration of Independence and said, you know, every citizen in the United States, and maybe even in Britain as well, is entitled to life, liberty, and the pursuit of happiness. But how are we doing with that? If you look at the average person, you know, you're living in a happy bubble here at Google. But the rest of those people out there, they're miserable, okay? People hate work. The only thing worse than going to work is being sick in bed. And the New York Times has even done an analysis of why people hate work. It's because, you know, they're working hard. They never have enough time. They never get to work on what they want. They're working late, they're working weekends, they don't have time with their families, they have no life, they have no freedom, and as a result, they're very unhappy. So, you know, the root of all this is, for most people, they're under the gun to deliver something, a product, a project, but as Robert Burns says, the best laid plans of mice and men often go wrong, and you wind up with a lot of pain and suffering instead of the promised joy. And I learned about this kind of thing as a cadet at West Point. Here I am at Beast Barracks. I'm being yelled at by a first-classman. After running around all day, being yelled at night we had what they call the shower formation. And what he's doing is telling me to get my chin in hard enough to drench my bathrobe with sweat, because only when you were drenched did you get to go into the shower. So I had to learn how to generate twice as much sweat in half the time. Okay, standing next to me is four-star General Barry McCaffrey. So I learned how to deal with really difficult situations as a West Point cadet. My last year there, I was actually got the job as training officer for my company, and it was Company L2. There were 24 companies in the Corps of Cadets. And one of the primary responsibilities of a training officer was to get the cadets to march really well in the formal parades. We had at least 3 of them a week, and they always had a lot of tourists there. The brass was all there. And the problem was my company was Company L2, and they had been known for 100 years as the loose deuce because of their sloppy performance on the parade field. And no matter how much overtime we spent marching, trying to get them to march better, the culture of mediocrity was just pervasive. So I decided I would try something very different. And instead of talking to them, instead of trying to coach them, I just started putting up on the wall in colored notes after the parade all the scores. You know, we lost 10 points because Charlie had his sword stuck in the dirt in the middle of the parade field. We lost 5 points because the platoon turning onto the parade field was not aligned. We lost 8 points because the company commander did not articulate the command at the right time. To everyone's amazement, within 3 months, Company L2 became the #1 marching company in the Corps of Cadets for the first time in 202 years. It's unbelievable. And it was all because of making the work visible. They self-organized to do a great job. And about that time, one of our most famous graduates died, General Douglas MacArthur. He was very close to the Corps of Cadets during the last years of his life. His last speech is memorized to this day by every cadet. And he had specified when he died that after laying in state in Washington, D.C., he was to be pulled by a riderless horse. His casket would be pulled by a riderless horse to his grave, and marching behind that casket would be a company of cadets. And so Company L2, being the #1 marching company in the Corps, was selected to bury General MacArthur. The last parade of the year, the graduation parade, my future father-in-law was there, and after the parade he said, "Jeff, who is that last company in the Corps of Cadets?" They seemed to float across the field. They were different than every other company in the Corps. I said, well, those are the guys that buried General MacArthur, and they will never forget it. So that taught me one of the first principles in Scrum. If you make the work visible, teams will self-organize to do great things. Another thing I learned at West Point from another famous graduate, General Eisenhower. I slept in his room when I was a cadet. He had a gold plaque on the mantelpiece saying General Dwight D. Eisenhower slept here. And sometimes the light reflecting off it would wake me at night, and I would think, you know, what was General Eisenhower thinking when he was a cadet? Well, he had a famous quote called, "Plans are worthless, but planning is everything." When he planned D-Day to take the beach at Normandy, he did a lot of planning. But he knew as soon as the first shot was fired, that plan would be shattered, and the teams would have to self-organize to take the beach. I learned about that firsthand as a fighter pilot. When I graduated, I went into the Air Force. Here's a photo of one of my fellow pilots getting blown out of the sky over Hanoi by a SAM missile. And what I learned is that if you follow the flight plan that you made over the most heavily defended airspace in the history of aerial warfare, you will get shot down. And in fact, about half of us got shot down. Most did not come back. Ed Atterbury was actually captured. He wound up in Hanoi Hilton. He was a tough character. He escaped, but they recaptured him and then tortured him to death. So that was a typical fate for half of my fellow pilots. So I learned when crossing the border that you needed to go into an evasive maneuver and never stop evading. And only at the last moment, in a very unpredictable way, would you pop over the target and then back in the evasive maneuver. So I credit my survival to not following the plan and a lot of luck. Now, when you come back from an experience like that, you have a lot of emotional reactions. You know, the first one is you feel guilty, like half of my buddies are dead and I'm alive, like it's not fair to them. And then the next feeling you have is exhilaration, like thank God I survived. And then the third feeling you have is like, well, what am I going to do for the rest of my life? I've kind of got a bonus life. You know, I should have been dead, but now every day is a bonus day. So I thought about it for a while, and I asked the Air Force to send me back to Stanford University to get an advanced degree to go teach at the Air Force Academy in the mathematics department. They agreed to do that, and that gave me a lot of time to think about life, the universe, and everything. I studied math, probability statistics, computer science. I spent a lot of time in the AI lab. You technical guys might appreciate it. Any of you Lisp programmers in here? Don't do any Lisp anymore? One of the two godfathers of AI was running the AI lab at Stanford, Professor McCarthy, and he would come by. I was there just as a student doing a project, and he would come by every day complaining bitterly because I was using 10% of the compute power in the AI lab for my checker program. I was writing a program that would play checkers and beat people and play against computers and that sort of thing. So I got christened very early on by some of the leaders in artificial intelligence at Stanford. I was also strongly affected by a mentor, Professor Kachadurian, on the left there. At the time, he was the chair of the Department of Psychiatry. He had been a student of my father-in-law, a very distinguished physician, who he viewed as a god. I could never say anything negative about him or I would be reprimanded immediately. But he took me under his wing and gave me some guidance. And my favorite courses, actually, at Stanford were in the medical school because the surgeons reminded me a lot of fighter pilots. They had the kind of same mentality. And the courses I was taking, they were mainly focused on biostatistics and clinical trials and things like that. But he advised me not to go into medicine as a clinician, but to build on my experience, brick by brick, build on what I already knew. As a result, when I got to the Air Force Academy and started teaching, I decided to continue my advanced degree work at the University of Colorado Medical School. So I would go nights and weekends. I would work on my degree while I was teaching math at the Air Force Academy. And one of the guys that was most important to me there was a guy named Dr. John Baylor. Now, he was the editor of the Journal of the National Cancer Institute, and he had just written a paper showing that there were more women that got cancer and died of radiation dosage from mammography than were saved by early detection. And the American College of Radiology was furious, so they wanted to tar and feather him and run him out of the United States. What happened is that the National Cancer Institute convened a blue ribbon panel that met for 6 months. At the end of those 6 months, they determined that Dr. Baylor was exactly right, and all the standards, protocols, and treatment for mammography were changed. And to this day, I noticed even the last year, they're fine-tuning that based on Baylor's recommendations. So I had a lot of respect for him as a person who would stand up for the right thing and deal with any flack that came his way and do something that's useful to society. So I said to him when he visited the medical school, I said, Dr. Baylor, I said, you know, I'd like to write a PhD thesis. Do we have any PhDs in here? Google hires PhDs, right? And a lot of PhD theses, they just wind up on the library shelf gathering dust, you know. And I said, I don't want to do that. I want to write something that is useful to people. Can you help me with that? So Dr. Baylor said, well, I have a couple of problems that have been puzzling me for some years. So he gave me 300 clinical papers. He said, here's 300 papers out of the medical journals, and in every paper you will see graphs. And the graphs are dose-response curves. You know, we put some carcinogen on the back of a rat, and it grew a number of tumors. And there were papers on rats, mice, monkeys, rabbits, also papers on different types of human cancers, different types of cancers in different parts of the world. He said, every paper has a graph that's different. Explain it, and then we'll give you a PhD. He said, the only problem, he says, you're going to have to model how a cell becomes malignant. And nobody knows how that works. So you're going to have to figure out what causes cancer, and then mathematically model it on the computer, and then map it to all the data at the National Cancer Institute. We have huge amounts of data on population-based data in many parts of the United States for many years, and we also have data on different types of tumors and so forth for different types of populations. So when your model starts at the cell and it maps how it grows into a tumor and then how a person winds up in a doctor's office and then how they get treated, and then that maps into all the data. See, that's a lot of this kind of stuff you're doing here at Google right now, right? Then you'll be done. He said, but don't worry, because the leading cancer researchers in the world are all submitting papers to me, and I will get them to review anything that you do, and we will kind of guide you step by step down the path. So at the time, we didn't understand what we understand today. Today, with the DNA sequencing, we know exactly what happens. You know, a cell starts, that bottom red cell mutates, turns into an orange cell. And then that orange cell may go in a couple of directions through mutations. And if it goes off to the left, if it goes to the right, it goes to leukemia. If it goes up to the yellow, it starts to turn into early non-malignant tumors. If it keeps on mutating, goes up into the green, then gets to the blue. Now you're starting to get the first malignant cell, which uncontrollable growth. Then you treat it with radiation and chemotherapy, and it mutates again, and you've got a drug-resistant metastatic tumor. We didn't know any of that back when I was doing my thesis. So I went to work trying to model a cell and made some assumptions about what needed to happen to change that cell. It took me about a year to complete the first program that I could run on the computer. And my first run used a third of the computer science department budget for the year in the medical school. They told me I could never run that program again. But what it did show is that there are exactly 4 steps to malignancy, which now we know from DNA research. So the work we did became the fundamental model for cancer today. So it has been very valuable. But the question was, I needed 1,000 runs of this program to get my degree, and what was I going to run it on? Well, the kind of computing that we did, you can see, this is actually a simpler problem later done at NASA. It's kind of evolutionary computing. Everything I did was based on evolutionary biology, and so is Scrum. Scrum is based on evolutionary biology. This particular example is for how do you build the best possible antenna transmitter for a satellite. Well, instead of having hardware designers, let's build evolutionary algorithms on a computer. And then we can run hundreds of thousands of millions of simulations, and we can wind up selecting the best antenna design. Today, we can probably put it in a 3D printer and print it. So the best thing is created untouched by human hands. It's just software, okay? This particular one, you can see, it was actually deployed on Space Technology Mission 5 in 2006. It was launched, and it worked perfectly. So in order to run this, this was done at the Ames laboratory in Silicon Valley. They needed a highly parallel system, 36 processors. And so my problem was, where was I going to get a system? This was 25 years earlier than NASA. Okay. Well, I went to work with the head of the computing lab, and about that time, Tandem had come out with its first multiprocessor systems, fault-tolerant, nonstop. And we decided to buy 2 of them, 2 multiprocessor systems, one for the hospital and one for the medical computing lab. And I was able, it had a unique architecture that enabled me to capture every spare cycle on every processor without interfering with the normal work on the computer. So for 5 years, every processor on these Tandem systems was pegged. And I could get a run to complete in about a week. It would take about a week to run to completion. But because the Tandem was fault-tolerant, nonstop, it always ran to completion. I became a professor in the university when I got my degree, a professor of radiology, biometrics, and preventive medicine. And I had millions of dollars every year grant funding from NCI to do cancer research, mostly mathematical epidemiology was my area. And because of the Tandem work we were doing, a large banking company came by one day, and they said, hey, you know, Jeff, you've got the best team outside of Silicon Valley for Tandem programming, and over at the bank, we're using these Tandems to roll out automated teller systems. They said, we're running 150 banks all over North America, and ATMs are exploding. We're having a lot of trouble with this technology. But, you know, over the medical school, you guys have all the knowledge, but over the bank, we have all the money. What if we put the knowledge together with the money? And they made me an offer that my wife couldn't refuse. She's sitting back there. I wind up as vice president for advanced systems in the bank, okay? Now, we had all kinds of programmers in the bank, but the largest group of programmers was COBOL programmers. Anybody programmed in COBOL here? They probably don't hire any COBOL programmers here. We have a COBOL programmer back there. And I looked at what they were doing. Their projects were always late. And the management were always upset. The customers were always screaming. They reminded me of, Romans rowing these galleons, harder, harder, faster, faster, guy cracking the whip. And I looked at what they were doing, and, I was just a guy from medical school. I had worked with Bell Labs. The guys that I was working with were like Kernighan and Ritchie, who invented C language. And they were giving me their tools, and we were emulating how they did it at Bell Labs with small teams. That's really where Scrum comes, the idea for Scrum comes from. But I saw these huge projects, always late, and they were run with these Gantt charts. They were much bigger than this one. The bank had one that would fill the whole wall of this room, thousands of tasks. Every task had a date and a name on it. And I looked at that, and as a mathematician, I said, if one of those dates is missed, they're all going to slide, and the project's going to be late. What's the probability of that? It's 99.999999999. Projects are guaranteed to be late if you manage them with Gantt charts. So I went into the CEO's office, and I said, these guys are crazy. They set up projects that are guaranteed to be late, and now the managers are running around, and they think if they have more meetings, more reports, and more micromanagement, they can actually bring them on time. I said, it's never going to work. I said, I want you to give me the worst business unit in the bank, which was the one running these ATM systems. It was bleeding the most red ink. And I said, I'm going to run that as one team with a bunch of small sub-teams. And I want to run it as a little company within a company. And every month we'll present our financial statements to you and the senior management. You can be our board of directors. And the rest of the time you stay out of my company. I don't want you messing it up, and then I will fix this. So he thought about it for a while, and he said, Sutherland, if you want this headache, you got it. So I said, I want everybody, sales, marketing, support, engineering, everyone. And we broke them into small teams. In the Scrum Guide, we say 3 to 9, but it turns out Harvard research shows clearly that the right size team, or the optimal size, is 4.6 people. So it's somewhere between 4 and 5. We ran them in short cycles, weekly sprints. At the beginning of the week, we built a product backlog that was prioritized by business value, particularly for the engineers that were coding. We had a financial expert come in from the bank and estimate the dollar value of every feature. That, combined with the work estimate, allowed us to prioritize. At the end of the week, they deployed those features. And in less than 6 months, it became the most profitable business unit in the bank. Okay, so this was the first prototype of Scrum. Now, in order to get rid of the Gantt chart and manage the product development successfully, this sliding off the end of the Gantt chart reminded me of training new pilots on how to land a high-performance jet. They were always coming in high, and if you came in high in one of these jets, you could wind up halfway down the runway before you touched down. If you did that, you could slide right off the end of the runway. It happened to me twice. Fortunately, the plane I flew was designed to land in an aircraft carrier, and it had a tail hook, and they had changed at the end of the runway. So both times I caught the hook instead of sliding into the buildings or the trees and creating a big smoking hole, okay, which is what would happen. So I thought about, here's the plane I flew, an R-4C Phantom. You notice coming down final approach, he's making small incremental changes every step of the way. He's looking at altitude, airspeed, rate of descent, heading. and he's constantly scanning and adjusting to bring that down. Those planes were designed to land on carriers, and that meant you slammed them on the end of the runway, and that would absorb a lot of shock and slow you down. So one of the goals was to bang it to slow you down. You'll see he's going to make a perfect landing. Bang, on the end of the runway. The chute pops. Nice landing, okay? So I needed them to do a project just like that. So what I added to the making work visible that I learned at West Point was the burn down chart. So they could see every step of the way exactly where they were on the glide path. Now, after fixing this business unit, the bank bought a company in Cambridge, right next to MIT, across from the business school at MIT, a new banking software company, new technology. And so I went there, and they had a project. Later, I consulted with Bank of America for the same project. Bank of America was spending $350 million to do what they were doing. It was already years late, and they wanted me to fix that. We had bigger problems than just the project planning because in order to get technologies that would scale to multi-billion-dollar banks, we wound up having to do things like build the first object database system for high-volume transaction processing. So I built a technology group out of MIT. We ran them as small teams. We started building these new technologies. And because of my work with object databases, I was hired in to run an object database company. And I was working away on the database company was right on the campus of MIT. I was working away in the object database company, and 5 graduate students came by. The MIT AI lab was just about 3 blocks down the street. They came by and they said, hey, we need some lab space to build our robots. We're starting up a robot company, which eventually became known as iRobot. And you have some lab space. Will you rent us a couple of rooms so we can build our robots? I said, sure, why not? It's interesting technology. And we have this space. We'll make a little extra money. So they're building these 6-legged robots, and about every other day, the robot escapes from their lab, comes walking into my office, trying to hunt me down. It had infrared heat-seeking sensors. And a senior professor at MIT was supervising the students, and he was a co-founder. He would come by on Fridays. One Friday, I asked him, I said, Professor Brooks, explain to me how this robot works. He said, first of all, you need to understand, for 30 years, we've tried to build an intelligent system at MIT, and it's been a complete and total failure. No matter how big a computer, how big a planning system, how big a database, nothing worked. The best we've been able to do is a smart chess program. So he said, what I've done is this robot has a chip in every leg that knows how to move a leg. There is no central processor. It has a chip in the spine that can coordinate legs. And it has a neural network chip in the head that figures out what to do. He said, here's the neural network chip. It's blank. He plugs into the robot, flips a switch. All of a sudden, the legs start flapping like spaghetti. And it wobbles to its feet, and then it starts walking around, banging into things. It looks like a baby learning how to walk. But within about 3 minutes, it's running around the room. I said, wow, that's amazing. He said, yeah, it learns how to walk for the first time every time you turn it on. So I thought for a minute. I said, I used to have these COBOL programs back in the bank, really, really slow. Maybe if we gave them some simple rules like the robot, they could sync their neural nets every day in a daily meeting. They could bootstrap up into a super intelligent, high-performing team. Do you think that would work, Professor Brooks? He said, I don't know. Why don't you try it? So I did. It's called Scrum. It's a bootstrap. Now, back when I was a professor of radiology, we used to use early computing, PDP-8s for radiation therapy. Anybody ever seen a PDP-8? You're probably all too young, maybe. And those, yeah, you saw it in use. The ones with the paper tape that starts them up. The early ones, you had to feed a paper tape into it. It had hundreds of lights on the front. You'd feed the paper tape in, You go zzz, and then whoa, all the lights would start dancing. It was like magic. And the paper tape was the bootstrap. So you still have that bootstrap on your laptop. It's in the boot sector on your disk. So what I find is about half of the Scrum teams out there in the world, they change an instruction in the bootstrap. You know, like if you went into the boot sector on your laptop and you changed a bit, and then you tried to turn it on your laptop, what happens? The lights don't come on, okay? So for about half the Scrum teams in the world, the lights don't come on. But if you run all the instructions, the magic happens. So we got this working. About the same time, a company, the first 4GL language company in the world, I think, Easel Corporation, the CEO had taken the company from a stock price of 3 to over 50. But then the stock was starting to go down because of a lot of competition. And so he went and he acquired a new technology company in Germany. And he came and talked to me and he said, Jeff, we need a new product suite to replace our whole 4GL language technology. We need it in less than 6 months. I bought a German company that has the base technology. I need someone like you that's built object database systems to come in and figure out how to get this new product out in 6 months. We'll give you a small team of the best people in the company, and the technology, base technology, the Germans have it. So it sounded like fun. So I said, sure, why not? So I come into the company and I watch these guys working with a prototype of the new system. We figure out with our we have really big customers like Ford Motor Company, 1,000 IT workers using our 4GL language to build all their internal apps. We work with these large customers. We figured out what they really wanted, and what they needed was a system where they could design what they wanted to build using, at the time there were many different object-oriented analysis designs, technologies. They've all converged pretty much into UML today. They could create a design, and then the system would auto-generate all the code, all the bindings to any relational database, an initial version of the user interface. Then they could dive into the code, change the code, and it would regen the design. So the first round-trip engineering kind of environment. It still exists today. It's called Object Studio, and it's used for wolfpack programming, where you can get a dozen people hacking the same code simultaneously. I went to a user group meeting one night, and in 1 hour we created a game that you couldn't create in a week by 12 guys hacking, okay, on the same code at the same time. And it's a Smalltalk-based environment, so every time you make a change, the virtual machine will immediately boot up and run. So I watched these guys working in this kind of environment, and I noticed they're trying to get this next feature to work, but sometimes they'll go days, sometimes even weeks, and they're struggling. It just won't work. But then all of a sudden, like magic, the feature works. And I watched that happening, and as an evolutionary biologist, I knew that over at Harvard University, Professor Jay Gould was writing papers on punctuated equilibrium. Now, punctuated equilibrium tries to explain why a species can go 1,000,000 years with no change, and then all of a sudden, it changes. And over at Thinking Machines, one of the first supercomputer companies, Denny Hillis was working with Harvard and modeling on the supercomputer, a highly parallel processing supercomputer, what happened, if a squirrel goes 1,000,000 years before it pops out of a tree and flies, what happens to the squirrel in the 1,000,000 years? What's going on when you don't see any change? And what he was able to simulate on the computer was that multiple parts of the organ systems make subtle changes, and only when 5 or 6 different major organ systems reconfigure themselves in exactly the right way does all of a sudden the squirrel fly out of the tree. So I said, guys, what you're seeing here is punctuated equilibrium, but it's in software. So we need to stop trying to create new features. What we need to do is ask ourselves, what is the smallest change we can make to push the system in the right direction? And we need to understand the component architecture of the software and make that change in the right component. We make that change, the system runs, we look at it, we say, okay, what is the next smallest change we should make? The only people that have understood this in the last 20 years are the Google guys in New York. They grilled me for 4 hours one night, and they would not give up until they found the secret sauce of Scrum. So maybe some of you will pick it up here in London. If you do this, the features will pop out like magic in less than 20% of the time. If you can do that, you become invincible. Nobody can compete against you. Now, the other thing that we had to change was, as we were building the system and the tooling that people were going to use the system, we were working on the organizational structure. How should the team be organized? How should it run? And we knew there were 3 major problems. One is Conway's Law. The structure of the organization will reflect in the code. So we knew Ford Motor Company had a hierarchical command and control culture. So that meant the code would be hierarchical command and control. That meant it would be a complete violation of good object design. It would be brittle code, hard to maintain, impossible to refactor. You know, you'd build out an architecture that would lock you in concrete, so the next feature that needed an architectural change, it was like impossible. So we had to create an organizational structure that would get around Conway's Law. The second thing we had to deal with was Brooks' Law. Brooks' Law says, as you increase the team size, it delays the project. In fact, we had data from hundreds of projects showing that if you take a team of 6 that takes a year to do a project, if you add 4 people to the team and make it 10, then they will take 18 months to do the 12-month project. Add 4 people, delays the project for 6 months. So we knew the team size had to be down around, we didn't know the magic number 4.6 at the time, but we knew, 6 people or less was probably the right number. The third thing we had to deal with was what Peter Drucker, who invented management, the concept of management, called the cuckoo effect. In a great book he wrote on entrepreneurship and innovation, he has a chapter on the cuckoo effect. And that is, if you do any innovation inside a company, except for Google, it will be perceived as an alien organism, like a bacteria or virus. And all the antibodies of the corporate culture will rise up and try to crush it immediately. Okay? Now, as a pilot, I knew about Lockheed's Skunk Works. And what Lockheed did was take a bunch of guys and put them in the desert in California where nobody could bother them. And then they could build something like the SR-71 or the first stealth bomber in 10% of the time at 10% of the cost. But I needed a system that would actually work inside corporate headquarters. And so the way Scrum teams are conceived and operate, they're able to evade the immune response of the corporation. Because in the early days, nobody ever approved Scrum. Okay? It was always stealth Scrum implementation by developers who wanted a better way of working. And so we need to build it out so that it would infinitely scale. And these double circles are like, we call it Scrum of Scrums. It's really a virtual team that coordinates the activities of multiple teams. So you could think of, one of them being Google Maps, has a bunch of teams making Google Maps. But then there's another team up here like Zillow's using Google Maps to add real estate prices. And then maybe somebody's using Zillow. So it enables a huge mashup. This is basically the way the internet is running, right? So this organizational structure became really important. How do you scale Scrum? Now, after all of this was pretty much put together, we needed a way to explain it to Ford Motor Company. So we started researching the literature, went through hundreds of papers. The best one we found was by the world's leading experts on knowledge generation in teams, Professors Nanaka and Takeuchi. And they had written a paper in 1986 called The New Product Development Game, in which they described 3 major styles of project management. Type A was the way NASA built rockets and the space shuttle. Big requirements documents, handed off to the analysis team. Took them years to get the requirements. Then the analysis team would take more years, another big document, handed off to the design team. More big documents, more years into implementation, more years into testing, more years into deployment. 10 to 15 years later, the rocket launches, it blows up on the pad, go back to step 1 and do it again. Nanaka and Takeuchi were consultants to Japanese management teams. They brought Fuji Xerox management to NASA, showed them how they worked, and Fuji Xerox came back and tried to implement that. But of course, as soon as they did, it's a fundamentally flawed model. We know today the failure rate is 86% with this traditional model of project management. So they immediately started getting failures. But the Japanese have been trained by Edwards Deming after World War II to do root cause analysis of failures. And what they found was big documents handed off between departments causes 4 out of 5 projects to fail. So they banned big documents and they banned handoffs and went to what they call the sashimi style of project management. Everybody's face-to-face all the way through. But the best teams, Nanaka and Takeuchi found at places like Honda, Toyota, 3M in the United States, lean companies, where the teams were cross-functional, working so closely together. In Paris, there are Google teams. They sit around a table all day. They have a Scrum board. Whenever anyone comes free, they go immediately to the top story on the board and work on it. It doesn't matter whether they know it or not. If you don't know it, you learn it. Okay? So everybody knows everything on the team. That's the way Toyota builds cars. If there is any impediment, that goes to the top story on the board, and the team works on that first. Radical cross-fertilization, radical impediment removal. You might go visit these guys in Paris. If you're not doing that, really fast team if you do that. They called Type B and Type C, reminded them of the game of rugby and the Scrum formation in rugby. So they said, we're going to call this Scrum Project Management. So we said, that's it. We'll call it Scrum Project Management. And then when we talk to Ford Motor Company executives, we say, it comes from Toyota. It's a car company just like you guys. And so, it'll be believable. And in there, they noted that all of these teams, the best teams, had 3 things in common. One, transcendent goals, like the Prius team at Toyota. The goal is to start greening the planet, get twice the gas mileage. All these teams had autonomy. They chose their work. They decided how to do their work. Nobody's micromanaging their work. And through cross-fertilization and cross-learning, they booted up into super-performing teams. And that really, that's an exhilarating feeling when you want a great team. So this transcendent goals, it's all about a better life for the world and for the people. Google kind of has that, do no evil. How's that working here? Autonomy, you have a lot of autonomy here at Google. I don't know how well you're working in teams here. It doesn't sound like you're working as well as the guys in Paris. I'm looking at your faces when I talked about that. Okay, real team performance requires real collaboration. So life, liberty, and the pursuit of happiness, having a great time, is fundamental to Scrum, okay? And it's based on lean product development at Toyota. We've been meeting with the lean people. I just came from the Lean IT conference, and they say, what Takeuchi and Nanaka were looking at was lean product development at Toyota. So this was all done in 1993-94 timeframe. In 1995, I called up my buddy Ken Schwaber. He's CEO of a project management software company. I said, Ken, I want you to come in and look at this new way of working. Those methodologies with the Gantt charts you're selling, they don't work, but I've got something that really works. He came in and spent 2 weeks with the team, and he said, you're right. So I said, what I want you to do, Ken, is I was working internal to the company. I want you to go out and promote this in the industry. We need to make it open source, free. And so he agreed to do that. 6 years later, we wind up in 2001 at a meeting of 17 experts on what they called at that time lightweight processes. The main processes were Scrum and extreme programming. And one of the Scrum guys had read this book called Agile Competitors, 100 hardware companies who were lean, but what they added was customer involvement and product creation. They called that Agile. And so he argued that we should call what we're doing in software Agile. That's where Agile came from. And the second day of the meeting, during a break, Martin Fowler, a famous author, went to the board. Actually, 9 of the guys went out on the ski slope, 8 of us back in the room. Martin says, it'd be really good if we could agree on something before we leave, because we've all been arguing and debating. What can we agree on? Well, the first thing we agreed on was great teams were the most important thing. And Bell Labs had done 10 years of research showing that the interactions of the teams was what produced great performance and great product. And we said, it's not that we don't like processes and tools, but the teams are much more important. Processes and tools can slow you down. The second thing we agreed on was having working software in short increments and deploying it and getting feedback is critical. It's not that we don't need some documentation. In fact, today we know for a medical device, you need 5% of the documentation that people used to have for FDA compliance. So you need some documentation, but a lot less. The third we agreed on is that getting the customer involved in the creation of the product, and Scrum as the product owner, is critical. And the fourth thing was responding to change over following a plan. We wrote all this in 15 minutes. After the break, the other 9 guys come back in. Ward Cunningham, one of the XP founders, the inventor of the wiki, there's a great article this week in the press on how Ward helped to create Wikipedia because he invented the wiki. He also invented the user story. He invented fitness, one of the acceptance test-driven development tooling. He was kind of the lead technical guy. He walked in, his mouth dropped, he looked at it, he said, "That's awesome," and not a single word was changed. So 15 minutes, we published this, and the whole world started to get agile. So major changes going on. And what's happened is it's changed the way people work. So here's the worst project in the world today. It's $143 billion over budget, the F-35. The latest delay is 13-month delay because of testing. And last month, one caught fire on the runway. They were all grounded. Here's the best airplane in the world. My company is a consultant to Saab Defense, the Saab Gripen. They build it with Scrum. Every 6 months, there's a new major release of the operating system, which is like a new release of Windows. It's probably as big as Windows. But along with that new release is all new hardware. So every 6 months, they have a new version of the plane. It's faster, it's lighter, it's cheaper, it has better technologies, better radar, better targeting systems. It is, by today, it's 3 generations ahead of the F-35. It is also the cheapest aircraft in the world. Less than 20% of the life cycle cost of the F-35. Less than 20% to buy and less than 20% to maintain. And we're seeing that in many different hardware scenarios. For example, in the middle there, you can see a John Deere piece of agricultural equipment. In John Deere, they use Scrum to manufacture that stuff. They get 700 or 800% improvement in productivity. And what we're seeing consistently is that the price tends to drop to 20% of the competitors' prices. So Scrum is spreading outside of software back into hardware where it started. It's also spreading across domains. You can see down in the bottom picture is Joe Justice. He runs our hardware practice. He's coaching a car company. They build cars in 1-week sprints. But it's spreading out in Silicon Valley. I had a group like this. I said, how many have run your wedding by Scrum? 6 people raised their hand. Anybody run a wedding by Scrum in here? It's great for weddings, but the leading implementation of Scrum today in the world is in education. And we see this both in the US and Europe, but the best implementation is EduScrum in the Netherlands. And I visited the school where it started. It's a high school, teenagers, and the bell rings and the kids come running into the class. They're in teams of 4, and they have these Scrum boards you can see in the slide with sticky notes. They immediately run to the wall, put it up on the wall, have a daily meeting. It's usually less than 10 minutes. They run to their seat and start working. The teacher just stands there watching. He says, I'm the product owner. I don't get to talk unless I have a question. I just ask them, make sure they're done when they're done with the assignments. I asked the kids, is it more fun doing this than the old way? They said, yes. They all screamed, yes. They said, we have a definition of fun for every story in addition to a definition of done. I said, what about your grades? They said, well, on a scale of 1 to 10, which they do in the Netherlands, the average grade is 5 in the waterfall classes, but in the Scrum classes, it's over 7. So really significant grade and performance. How about speed? They said we finish weeks early compared to the rest of the classes. One of the most interesting things I noticed was a handicapped girl in a wheelchair came wheeling in. She's right into the daily meeting, running to the desk with a wheelchair, just like everybody else, and totally involved as a first-class citizen in working. They told me she can only be there 2 days a week. But because of the way Scrum works, it just totally gets them engaged. And one of the kids who had been autistic and could hardly talk to anyone 2 years earlier, he said, autistic kids are real valuable players on these Scrum teams because they're great at visualization and planning. And he said, I became a Scrum Master, and he described what he was doing and how he was leading the team. This kid who could hardly talk had become a great communicator and a leader. It absolutely transforms the kids. And the teachers say virtually all motivation and disciplinary problems just go away. The teams are self-managing. One of the girls said, I went home for family dinner a couple of weeks ago, and my father was really depressed. And the family asked him, why are you so depressed, Dad? He said, they implemented Scrum in my IT group today. So the daughter says, well, how did they do it? What are you doing? And he explains. He said, you're doing it all wrong, Dad. You have to do this, you have to do that, you have to do. So in the future, your children are going to be training you how to have better teams here at Google, if we can get it into the UK school system. So all of these stories and many more, this book is really a book that's beyond IT. The goal was more than 80% of the stories outside of IT, where Scrum is going, and all these stories that really are the background of Scrum and where it comes from, because it has nothing to do with software. It comes out of fighter pilot experience and evolutionary biology and supercomputing, modeling, AI. That's where it all comes from, capped by the Toyota Lean product development experience. So I think you got books for everybody, right? So hope you read it and enjoy it.
Yes, we have books for those of you who came early and sat up front. We have time for just a couple of questions, and I'm going to ask you to use the mics. Any questions?
Hi. So I've been using Scrum a bit, and I've really enjoyed it. And my question was about the burn down for 1 week sprints. What's the value of that? When it was the Schwaber 30 days, you could get some kind of trajectory. But when you only have 5 days, it's very hard to correct something that's gone out of, when you've already had 2 or 3 days, there's not a lot of opportunity to change.
That's what people say when they're starting off with Scrum. But in my company, we run our company completely by Scrum. We run all in 1 week sprints. We use some tooling because we have a lot of distributed people. It has a burn up instead of a burn down, but it gives us quite a good visualization of what's going on. But for a lot of companies today, particularly Google and Mountain View, I don't know how you're working here, you're in a continuous delivery mode. So you figure out how much you delivered this week, burning up. Is that happening here? Are you guys delivering stuff every day to production? Yeah. So you just burn up for a week. Most companies today don't use 4-week sprints anymore. I mean, Ken still likes 30 days, but probably 70% of scrums today are 2 weeks, few 3 weeks, few 1 week. We find that 1-week sprints are more intense, so you have to have a team that wants to really be focused and disciplined. And if you do that on the weekly cycle, you get more learning. It's really the learning cycle that propels the product.
I've worked at a couple of different companies that have done Scrum, and there seems to be quite a vastly different interpretation from company to company. Was that kind of the intention of Scrum? Were you leaving it very open to interpretation, or do you find that Scrum is kind of misrepresented by some companies?
Well, the Scrum guide, we try to keep minimal, the middle framework. But the misinterpretations that we see are really extreme. About half of the Scrum teams in the world can't deliver anything. And so they're not doing it the way Ken and I are talking about. We have Scrum teams that are spending a year doing 2-week sprints for requirements for 6 months. And then 2-week sprints for coding with no testing for 3 months. And then they're never done, so the project's always late by this time, and they think that's Scrum. So, people totally misinterpret what we're talking about. There's nothing we can do about that other than it makes for a lot of coaching business. There's a lot of Scrum coaches out there that have good jobs.
Okay, we have time for one last question.
I got it, Mike. Hey, so thank you very much. That was a really great and motivational talk, so kudos for that. But for those of us who didn't come early enough to sit in the front row to get a book, or for those of us who are just new to Scrum, could you maybe just go into what that recipe is to make the secret sauce? I mean, really bang through it. You said, the bootstrapping, can you just describe that to us?
Okay, the bootstrap is the Scrum guide. Often people say, why do we have to do this? You need a product. You need a list of stuff to do that's in a ready state. That means it's immediately actionable and it's small. So you have to do whatever needs to be done before you enter into that sprint. If that's not clear, then you have a mess. Okay, so that's the first secret. The second secret is when you start into that sprint, you want to take just enough and not too much so that you can cleanly complete it in the sprint. The reason being, we have discovered, I work for a venture capital group, and after running thousands of sprints, we have found that teams that finish the sprint early with everything done and working accelerate faster. So the kind of improvement that we're looking for requires you to cleanly finish, and in your case, you should be able to deploy in whatever sprint length you're having. So you don't want to take too much in. So that sprint planning, it can be 1 minute, but you need to make a decision to take the right things in and not too much.
Oh, when you're talking about 1 week, that almost sounds like a Gantt chart style planning. So really the 1 week is kind of like a rough estimate. If this is how much work we should get done in 1 week, and now it's let's just burn through it. Or are you really looking at 1 week and then either coming in early or late?
This is a long discussion about planning, but for a lot of things in Google, you don't care when it comes out, right? It comes out when it comes out. But for some projects, people need to plan and they need to predict, and the product owner needs to be able to give dates. This happened in AdWords. That's why they implemented Scrum at AdWords many years ago, because they needed to be more predictable. There were millions of people using AdWords. So in order to get that, the product owner needs to know a velocity of production, and he gets that off the sprint cycle. Also, we find that people that cleanly finish work in a cycle need to take the right amount in. So knowing what they can do is important to get in this rhythm of a planning cycle. People often think, well, we can just do one thing at a time. We'll just do one thing at a time and don't worry about it. Those teams don't go as fast. People that say, okay, this week we're going to get this stuff done, bang, they get it done. Then next week we're going to get more done, bang, they get that done. Those teams, really accelerate. It's like winning a soccer game.
I'm just going to keep going. So kind of like your punctuated equilibrium thing. So when you're looking at this, it really should be a small change that you can do in 1 week, which is setting you off in the right direction. No
Exactly.
change should take more than the sprint.
Right, exactly.
Great. Okay, so we're going to end it there. We actually will have copies of our books in the libraries, and I'd like to say thank you
Okay,
to
thank
Jeff.
you for inviting me.